Alright, so this is the test review. The first day I asked that you do every third problem, so that's numbers 3, 6, 9, 12, 15, etc. So that's what this video is going to cover. So, number 1 through, 1 through 3 are all dealing with the information right here. So this information, angles A and B are in standard position. Let sine of A equal 3/4 and cosine of A be greater than 0. Then it tells us that tangent of B is 8/15 and sine of B is less than 0. Draw angles A and B, then find the following. Well, even though I only have to do number 3, I'm not going to be able to do that if I don't draw the triangles. So I am going to still draw the triangles, and I'm going to do it just in this section, but you might want to do it up here so that you can have room for these questions. But I'm going to do that over here. So this information is dealing with angle A. So this is my information about angle A. So it tells me that sine of A is 3/4 and cosine of A is greater than 0. So let's talk about all students take calculus. So all students take calculus was how we remember which trig functions are positive in which quadrants. So in quadrant 1, this says all of them are positive. In quadrant 2, sine and cosecant, but sine is positive in quadrant 2. Only sine is positive in quadrant 2, and cosecant. In quadrant 3, tangent and cotangent are positive in quadrant 3. And lastly, quadrant 4, cosine, so the C is for cosine, and then the brother secant is also positive in quadrant 4. So I'm going to highlight sine of A is 3/4. If you want sine of A to be 3/4, first of all, is 3/4 a positive or negative number? So 3/4 is positive. So in yellow, I'm going to highlight where sine is positive. Well, all of them are positive in quadrant 1, and sine is positive in quadrant 2. So I've highlighted sine of A is positive in yellow. Okay? All right. Now, in red, I'm going to highlight cosine of A. Sorry, but in red, I'm going to highlight cosine of A is greater than 0. So greater than 0, does that mean positive or negative? Think of any number that's greater than 0. So 100. 100 is greater than 0. So it's a positive number. So where would you highlight red if you want cosine to be positive? Well, in quadrant 1, all of them are positive, and in quadrant 4, cosine is positive. So the benefit of highlighting is you can really see where did you highlight both things. So in quadrant 1, I highlighted 2 times. I highlighted the yellow and I highlighted the red. So I'm going to be in quadrant 1 for angle A. So I'm going to draw quadrant 1 for angle A. So go ahead and make your quadrant 1. So I'm talking about angle A is in quadrant 1. And I know, so I kind of need to go back and see this. I know that sine of A is 3/4. So we have to use this information to know if sine of A, what the ratio of sine A is. So I have a triangle whose opposite is 3 and hypotenuse is 4. So I can label 3/4. All right, if we think of a right triangle, it satisfies Pythagorean theorem. So A squared plus B squared equals C squared. So A squared plus 3 squared equals 4 squared is 9 plus 16 So is 7, take the square root, so we get square root of 7. And then it's a good idea just to check your negatives and positives. So I went to the right, that's positive. I went up, that's positive, and the hypotenuse is always positive. So all of this is angle A. So angle A is this picture. This represents angle A. All right, now do all that same thing for angle B. So if you want to pause it and see if you can do angle B on your own, you can go ahead and do that. I'm going to start. Oh. All right, so now I'm going to do angle B. So look at where you know angle B information about angle B. So this is all of my information about angle B. So I erased my former all students take calculus. I'm going to do it again for angle B. So if you have 2 more colors of highlighters, that's what I'm going to do here. And I'm repeating that process. So for the first part, tangent of B is 8 over 15. I'm going to highlight that in this light colored blue. So tangent of B is 8 over 15. So 8 over 15, is that a positive or a negative number? So 8 over 15 is positive. It's positive 8 over 15. So where is tangent positive? So tangent is positive in the first quadrant, because all of them are positive in the first quadrant, and tangent is positive in the third quadrant. Okay? All right, the second part I'm going to highlight in red. So where is sine of B less than 0? Well, this is less than 0, which is a negative number. So you want sine to be negative. So where is sine negative? Well, in quadrant 1, all of them are positive. So is sine negative? No, it's not. All of them are positive. I just said that. So not quadrant 1. Okay, in quadrant 2, sine is positive. That's what the S stands for. Sine is positive. I want sine to be negative. I'm not going to highlight quadrant 2. In quadrant 3, tangent is positive. So tangent is positive. All the other guys are negative. So I'm going to highlight quadrant 3. And also quadrant 4, cosine is positive, only cosine. Therefore, sine is negative. I'm going to highlight quadrant 4. So where I highlighted 2 times, it's got to be both times. That's where your answer is. So where I highlighted 2 times was in quadrant 3. So angle B is in quadrant 3. Let's go ahead and mark that. So this is my angle B. And I also know that this angle has the ratio for tangent 8 over 15. So opposite is 8 and adjacent is 15. Now, if you're thinking about quadrants, hopefully you are, you're thinking, well, both of these things would be negative because I went left and down. But tangent showed me a positive ratio. So it should make sense, actually, that it shows a positive ratio, because if you think about what happens with negative 8 over negative 15, the 2 negatives cancel, and that's why it became positive. All right, I do have to do this Pythagorean theorem, and this is going to be a little bit heavier than the last one, because I don't have this. Or it's not quite as simple of numbers. So it's a squared plus b squared equals c squared. So negative 8 squared plus negative 15 squared equals c squared. So that's 64 plus 225. So let's see, add 64 is 2, 8, 9. And then 289, I'm not sure if you know this, but this is a perfect square of 17. The only way to really do that, I mean, you could break it down as far as you could, but that's going to be hard. So 17, 8, 15, 17 is another triple. 289 is the square root, or the square root of 289 is 17. All right, let's keep going. So all of this work, and I haven't really begun my question yet. I need to find, I'm on number 3 now. cosine of A minus B. So the whole point of this is that this is what angle A is, and this, let me show angle B. All of this is what angle B is. But I don't know what those actual numbers are. It's not like I can say, well, A is this degree, 10 degrees. I don't know what this angle is, and I don't know what this angle is. All I know is that it results in this triangle and in this triangle. So therefore, you cannot subtract A from B. You don't know what they are, so you can't really subtract them. So the only way to evaluate this is to expand it using our expansions rule. So cosine of A minus B. So looking on your formula chart, I want you to look at your formula chart, match cosine of A minus B, and it matches to cosine A times cosine B plus sine A sine B. So you need to write that down. So cosine A, I'm going to have to go back and forth to see my triangle. So cosine A times cosine B plus sine A sine B. All right, now cosine of A. This is something I can evaluate because I know this is angle A, and cosine of an angle is equal to the ratio adjacent over hypotenuse. So the answer to this is adjacent over hypotenuse, root 7 over 4. Now times. Now I'm going to do cosine of B. Well, now I need to look at angle B. So I'm going to have to come over here and I'm going to do cosine again. So cosine of B, so this is my B. Cosine of angle B is equal to adjacent over hypotenuse. So negative 15 over 7. I'm sorry, over 17. So negative 15 over 17. Now I have a plus sign, sine of A. So here's my angle A. Sine is opposite over hypotenuse. So that's 3 over 4. And then sine of B, so go back to your B triangle, is opposite over hypotenuse, negative 8 over 17. All right, so from here, I'm going to do some algebra work. So I multiply first, so root 7 times 15, negative 15 is negative 15 square roots of 7. And then 17 times 4 is 28, carry the 2, 68. Okay, now I need to do the other half. So, plus 3 times negative 8 is negative 24, and 4 times 17 is 68. All right, now I need to do this. The great thing about sines and cosines is you always end up with these common denominators. So that's going to come to final answer, negative 15 square roots of 7 minus 24 all over 68. This is your final answer for number 3. Now, the great thing about this problem is that even though it kind of took us a while to get started, this you use for number 1 and also number 2. So you don't have to redraw those triangles every time. We just drew that one triangle for angle A and draw the one triangle for angle B, and that's what you're going to use for number 1 and 2. All right, so I'm going to go on to question 6 as the next one on our homework tonight. All right, question 6, cosecant of 15 degrees. So for these exact values are generally used for like our 30, 60, 90s and 45, 45, 90s. So if you look at this angle, it's asking you cosecant of 15 degrees, which is neither one of those angles that we know. But 15 degrees is, however, the composite of 45 degrees minus 30 degrees. So that's what I can consider for cosecant of 15 degrees. So instead of thinking about cosecant of 15 degrees, I'm going to think about cosecant of 45 degrees minus 30 degrees. All right, so this is our composite. When you have things in parentheses that are added and subtracted, you should be looking at your formula chart. Now, you could look all day, and you're not going to actually find this exact thing. And that's because it doesn't have any of the reciprocals written on it. Cosecant is the reciprocal of sine. So instead of doing this, I can do 1 over. So if I'm flipping it, I'm no longer using cosecant. I'm using his reciprocal, sine of 45 minus 30. Okay? So really all this is going to do is that when we're going to find sine of 45 minus 30, that's going to give us the answer to sine of 15 degrees, which is this guy's reciprocal. So then we're going to flip it because that's what reciprocals mean. So I'm going to take this and I'm going to expand it according to my rules of expansion. So 1 over, so my rules of expansion, sine 45 minus 30. So looking at your formula chart, you see sine A minus B is equal to sine A cosine B minus cosine A sine B. So if I need to write that, I'll go ahead and do that. So sine A minus B is equal to sine A cosine B minus cosine A sine B. So I'm going to write all of this, but using 45 for A and 30 for B. All right, so sine, let me do it in red because I'm writing this using the expansion. So sine of 45 times cosine 30 minus cosine 45 times sine 30. All right, so this becomes actually kind of similar to that problem we just did, where even though I couldn't evaluate it as a group, now I can evaluate each thing individually. So I can evaluate these things individually. So what is the evaluation of sine of 45 degrees? Well, if you want to come draw your 45-degree triangle, it's 1, 1, root 2. And I also need, while I'm drawing triangles, I'll also draw my 30-degree triangle. And that's 1, root 3, 2. All right, so equals. So I'm still on number 6. Hopefully you can write a lot smaller than what I'm writing. 1 over, so sine of 45 is equal to opposite over hypotenuse. So 1 over root 2. Cosine of 30 is root 3 over 2. minus cosine of 45 is 1 over root 2. And sine of 30 is 1 over 2. So I don't need those triangles anymore. So equals 1 over. So what is 1 times root 3? Well, that's just root 3 to root 2. Minus 1 to root 2. Equals 1 over. So they already have a common denominator. So root 3 minus 1. All over 2 root 2. So this is what sine of 15 degrees would be. So that's why we did 1 over, so we're just going to flip this around in order to get the cosecant answer. That's what 1 over means. So it's going to be 2 root 2 is on top, root 3 minus 1 is on bottom. So 2 root 2 over root 3 minus 1. So that's the answer to number 6. Okay. All right, number 9. All right, so number 9, rewrite each expression with a positive argument using the odd and even properties. Well, that's interesting, because if you look at number 9, it's already got a positive argument, so it is what it is. Cotangent 3 pi over 7. And that's it. All right, number 12. Cosine A plus B times cosine B minus sine A plus B times sine B. So this I can say is A, capital A. So I have capital A here. This I can say is capital B. So I have cosine capital A cosine B minus sine capital A sine B. So where do you see cosine A cosine B minus sine A sine B? So that's the same thing as cosine A plus B. All right, so cosine A is little a plus b, and capital B is lowercase b. This is kind of confusing because it's capitals versus lowercase, but cosine of A plus 2b. All right, let's go on to number 15. All right, so number 15 is tangent x minus 90 equals negative cotangent x. So I've seen this done a couple of times, and a lot of people try to do the tangent rule. And if you try to do the tangent rule, that's tangent A minus B, so that's tangent x minus tangent 90 all over 1 plus tangent x times tangent 90. Now the problem occurs right here. If you try to evaluate tangent of 90 degrees, the opposite is 1 and the adjacent is 0. So opposite over adjacent is undefined. And you cannot add or subtract to undefined. So this is basically like a hold still. You can't go any further using this as your method. So you have to find a different way to do this problem. So the other way is think about how else we've learned to evaluate tangent. So from the very beginning, we've defined tangent as sine over cosine. So we could say that's going to be the same thing as sine of x minus 90 over cosine of x minus 90. Well, sine of x minus 90, looking at your formula chart, is sine A minus B, sine A, cosine B, minus cosine A, sine B. So I'm going to expand that. So that becomes sine x times cosine 90 minus cosine x times sine 90 all over. So the denominator, cosine x minus 90, I can rewrite as cosine A minus B, so cosine x times cosine 90 plus sine x times sine 90. So I still need to be able to evaluate that 90 degree. Look at all these 90s. I do need to be able to evaluate 90 degrees, but now we're not going to get undefined, so it's okay now. So this is 90 degrees. So once again, your opposite is 1, your adjacent is 0, your hypotenuse is 1. So if you want to write that down, opposite is 1, adjacent is 0, hypotenuse is 1. All right. So equals. You cannot evaluate sine of x. If you don't know what x is, you don't know how to evaluate it. You just simply can't evaluate that. So I'm going to rewrite sine of x. Okay? Now, cosine of 90 is something I know how to evaluate. The evaluation of cosine 90, this evaluation is adjacent over hypotenuse, which is 0. Now I have minus, once again, cosine x, don't evaluate that, but sine of 90, this is an evaluation I can do. Sine of 90 degrees is 1. All right, let's keep going. Cosine of x, that does not have an evaluation. However, cosine of 90, we've already done that evaluation. That was 0, adjacent over hypotenuse. Minus sine of x, we don't have an evaluation for, but sine of 90 was 1. We've already done that as well. So what happens when you multiply times 0? It goes away, it goes away. All you're left with is timesing 1, which is great. Negative cosine over sine is exactly negative cotangent, which is exactly where we were trying to go. All right, number 18 is the problem we're on now. All right, so I'm on example 18. Let me erase all this. All right, so, or number 18. 1 minus 3 cosine x minus 4 cosine squared all over sine squared. So I think we've done this problem on a notes before, but if you take this top and you factor it, that's going to be the way we want to solve. So when you factor, you say what multiplies to 1, so that's 1 and 1. And what multiplies to 4, yet we'll add to 3. So that's a 4 and a 3. I'm sorry, not a 4 and a 3. 4 and 3 multiply to 12. 4 and 1 multiplies to 4. But we don't need just 4. We need 4 cosine squared. So that's 4 cosine x and 1 cosine x. Now, there's either a plus or a minus here. We got to figure out which one is which. So if you want to add to negative 3 but multiply to negative 4, what adds to negative 3? Well, that's negative 4 and positive 1. All right, and then in the bottom, since in the top you have all of these cosine squares, you don't really want to consider sine squared, so I'll think about 1 minus cosine squared, and then that is the difference of squares. 1 plus cosine x, 1 minus cosine x. And so this cancels with this, and we're left with exactly what we want to be left with. All right, let's go on to number 21, I believe is our last problem. All right, so on number 21, cosine of A times B minus sine A B plus sine A cosine B plus cosine A sine B. All right, so if you match this up, look at your formula chart, you can match that up actually, and you're going to see that it matches up to cosine, I don't know why I put this in parentheses, well it's okay, cosine of A plus B. And then you still have that squared. And then plus, this matches up to sine A plus B squared. So we end up with cosine squared plus sine squared, which equals 1. And that's it.